Okay, welcome back to Binomial Theorem Part 2. This is the example I wanted to get to and we ran out of time, but that's okay. First things first. It's very helpful. I didn't mention this in the last one, but if you look at an expansion here and you wonder, well, I wonder how many terms there are in the end. It's always one more than your exponent. So just as a little note to self, the number of terms that I should end up with here is 5. Okay? So whatever your exponent is, you're going to have one more than that as your total number of terms. The other thing that's important is to analyze these things piece by piece. And to start it off, because it's only raised to the 4th and we had Pascal's triangle sitting there, it's easy enough to look at what the coefficients are, but suppose this was a much bigger number. Here's how you get your coefficients. So let's start off with that. Let's just get what the coefficients are. Okay, the numbers out in front. Okay, the quick way to do it is to use the choose stuff. So you're going to have 4 choose 0. Now, how did I know this was going to be a 4? Because this is a 4 up here. Whatever this exponent is, that becomes the n value in my choose notation. So 4 choose 0, and then the next one would be 4 choose 1, then 4 choose 2, 4 choose 3, and finally 4 choose 4. So here's what the coefficients look like. That's a 1, and that's a 1. When you go 4 choose 1, no matter whatever n is, that's what this whole thing here is. So I know even before reaching for a calculator that that's going to be a 4, because you got 4 items and you're choosing one of them. Well, how many different ways can you do that? Well, it's equal to n, which means this one here is also going to be 4. And if you go 4 choose 2 on your calculator, you'll get a 6. Okay, so what I now have are my coefficients. Next thing I got to do is I got to do the 2a stuff. Okay, so I'm going to try and plug that in. Well, remember how it started off? It was the 2a stuff starts off to the same degree as this exponent here. So it's raised to the 4, so this will be 2a to the 4. Now that you're going to want to expand out. 2 to the 4 is 16, and then we have a to the 4. Okay, then it becomes 2a cubed, which again you want to work out. That's going to be 2 cubed is 8, and then a cubed. And the next one's going to be 2a squared, which is 4a squared. Then the next one is 2a to the 1, which is just 2a. And then it disappears. Next thing I got to do is I got to do the negative b. And you notice this time it is treated as a negative. That's because it's minus b in my binomial. Now, it won't be in the first term. Actually, maybe I'll start at the end here. It's probably easier. Okay, but remember, it's negative b. So negative b to the 4, which turns into positive b to the 4. Okay, so the negative kind of disappears on that one. In this term, it's negative b cubed, so that's going to stay negative b cubed. Okay, I better put equals. Then the next one is negative b squared, which we know is going to turn positive. And then this one's going to be negative b to the 1, which will stay as negative b, and then it disappears. Okay, so these guys are blank. All right, I think I can just squeeze them in at the bottom. So what we got to do is, this is all part of the first term. The coefficient is 1. This has a value of 16a to the 4, and this one doesn't exist. So my first term is 16a to the 4. Okay, then we go to the next term. What do we got to put together here? Well, we got 4 times 8a cubed times negative b. So it's going to be negative. The number is going to be a 4 times that 8, so that'll be 32. Then we have an a cubed, and we have that b. All right. Then we go to the next one. 6 times 4a squared times positive b squared. So it'll be positive. And the 6 times the 4 is 24. And then we had a squared, and we have b squared. On to the next term. We have 4 times 2a times negative b cubed. So it'll be negative, and it looks like 8, and just one little a, and 3 b's. Okay, and then the last one is 1 times nothing times positive b to the 4. So I put all my ingredients together, and this is the expansion. The binomial theorem in action. All right, good place to stop, I think.